Hello friends, today I am going to solve LeetCode problem number 946, validate stack sequences. In this problem, we are given two integer arrays, pushed and popped, and each of these arrays have distinct values, and we are going to return a true if the two arrays can be formed by a sequence of push and pop operation initially on an empty stack. Otherwise, we are going to return a false. And there are a few constraints given to us. The length of the pushed array is at least 1 and at most 1000, and each of the element is a value from 0 to 1000, and all the elements in the pushed array are unique. Similarly, the popped length of the popped array is equals to the length of the pushed array, and popped is a permutation of pushed array, which means that the elements in the popped array is also unique and is a permutation, that is some arrangement of the elements of pushed array. Now that we know the question and the constraints, let's look at this example here. So we are given this popped array and pushed array and the popped array. Okay, so here in this example, this array, pushed array, is a sequence formed when we are pushing some elements in our stack, and the next one is the sequence formed while popping out of the stack. So let's take this first array here. So if we push into a stack, then this sequence is formed because we are pushing the first element, which is equals to 1, and next we are pushing the second element, which is equals to 2. Next element we push is 3, next element we push is 4, and the next element we push is 5. But the pop sequence is starting from 4, right? So when from where do we pop in a stack? We pop from the end, right? So since we are popping 4, so that means that we are popping from our stack when the stack has the element 4 at its end, which means that, let's look at this sequence here. So we are pushing the first element, which is equals to 1, right? So these are the pushed array, sequence of the pushed array, and this is the pop sequence. Okay, and this is our empty stack, and we are performing the operation on an empty stack, right? So now we are pushing the first element, which is equals to 1. So we push the first element, which is equals to 1, and the popped element is still equals to 4, right? So we push the second element, which is equals to 2. We again push the third element, 3, and then the fourth element, which is equals to 4. Now in the pop sequence, we see that the first element is equals to 4, right? Which means now that the stack has the last element 4, we now pop this element 4 out of our stack. So we pop this out of our stack. So after 4 we are popping the element 5, right? So now we are popping the element 5, and after 4 we are pushing the element 5. So let's push the element 5 here, and then we see that the element 5 is the last element, and since we are performing pop in the sequence, so we pop this out of our stack, and then we do not have any more push elements to push, right? But our pop sequence has the next element, which is equals to 3, and our stack has the last element, which is equals to 3, right? So we pop this out, and the next element here is equals to 2, which is the last element in the stack. We pop that also, and the next element here is equals to 1, which is the last element in our stack, so we pop that out. So finally the resulting stack that we get is we pushed all of these elements, and we were able to pop all of those elements in the given sequence, right? Which means that the sequence is correct for pushed and popped sequence is correct for this stack, because finally we have an empty array. stack, right? So that is when we return a true. Now let's look at this example. We have post and pop sequence, right? So the pop sequence is 4 3 5 1 2. Okay, so 4 3 5 1 2, and push sequence is same as the initial example. So now let's do the same thing. So we are popping out at first when our last element is equals to 4, right? So we are going to push until and unless we get the last element which is equals to 4. Now since 4 is equals to the last element, we pop that out, and then again we see that the next element in the popped is equals to 3, which is again the last element. We pop that as a. Now the next element here is 5, which is not the last element, right? So we go back to our pushed array and then we push the element, next element, so that is equals to 5, and we see that the next element in the popped array is also 5. So we now pop that out. Okay, so here actually our example has a sequence of 5 1 and 2. All right, so now we popped 5 out of our stack, right? Now the next element in the stack, the last element is 2. However, the next element in the popped array is equals to 1. So since these two elements are not equal and we have already pushed all of the values, and our stack still has 2 more elements remaining, right? So that would mean that our we were not able to pop out all of the elements that were pushed to our stack. Hence the sequence, this push and pop sequence are not the sequence this push and pop sequence cannot be performed on the given stack, right? Because we were able to perform the push, but we were not able to perform the pop, right? We only were able to perform the pop for these 3 elements and not these 3. So we are not able to perform these 2 operations on this given stack, hence we return a false. So that is all that we need to do. We are actually going to create a new stack and perform the push operation and the pop operation on the stack. So let's start coding, and we start with our base condition. So we check if push dot length is equals to 0, we return, maybe we are going to return a null here. And if pushed dot length is not equals to popped length, gth length, then is when we are going to return a false. Right now we need a stack where we are going to perform our push and pop operation, and then we are going to perform the operation while I is less than pushed length. Okay, so before we perform a pop operation on a stack, we should first of all push something to the stack, right? We cannot perform a pop operation on an empty stack. So that is what we are going to do at the first step. We push to our stack the first element that we have in our pushed array. Now we have pushed the element in the stack. We check if that is what we are popping out of the stack, because we have one element right now. We could actually pop out of the stack. So we check if the first element matches the last element in our stack. So while okay, stack and stack the length minus 1, which gives us our last element, is equals to the popped index j. Okay, so we actually need to define our value of I and j. So I is an index that points to elements in pushed array, and j index is used to point to elements in the popped array. So if it is equals to popped j, the last value at stack equals to the current value at index j, that is when we are going to perform the pop. So we pop out and then we increment the value of j here. So one thing we also need to keep in mind is that as we are popping out of our stack, we might go we might have performed the pop operation for all the values in the stack, and we still have some more values for the popped remaining. So we need to actually check if the length is greater than 0, because only then we are able to perform the pop operation, right? So we check if the stack length is greater than 0 and the last element matches the value at our current index in the popped array. That is when we pop and increment the value of j, and finally we increment the value of I, and then finally we are going to return stack the length, and we are going to use this exclamation mark which denotes a not. That is, if the length is equals to 0, then boolean of 0 in JavaScript is equals to false. So this not operation will return a true when the length of the stack is 0, right? That is what we need. If length of the stack is not 0, it's going to return a false. So now let's try to run our code and look at the solution. All right, let's submit this. Awesome. So let's talk about the time complexity and the space complexity. Since we are using a stack which adds to our space by the length of the pushed array or the popped array. So if the length of the array is equals to m, then our space complexity is O of n, and since we are iterating over each of the element in our pushed array, right, so that is why our time complexity is also O of n. So yeah, that's all from this problem. I hope you liked my solution, and let me know in the comments down below, and if you have any feedback, just let me know so that I can improve on those. And thank you so much for supporting me, and yeah, have a great rest of the day.